just a quick bit about myself. I'm a PhD student at UC Davis. I do work on power-related issues for embedded systems, and in particular, mobile systems. I'm an embedded software engineer, worked for Motorola and BMW in the automotive industry, and last summer I was working for Broadcom on Android platforms. And I also have my own consulting company, so I do training, book reviewing, speaking, that sort of thing. So I've been doing Android for basically since the beginning, since I'm a PhD student and I have the time for that. So I like to think I have a pretty good handle on the different layers of the platform. So hopefully I can answer all your questions. So briefly, I'm going to talk a little bit about how Android is different from the other platforms. One of the biggest differences, in my opinion, is the great documentation for developers. So let me just give you an example here. When you're a developer, the API reference is definitely your best friend. So if you go to, I'm reading this one off of my computer right now, but if you go to developer.android.com, they have a Javadoc style reference to all the different packages and the whole API here. So it's really easy to go around and find information on what you need straight from the API. So let's say we're looking for Bluetooth, for example. Let's see if we can find that here. Right there, android.bluetooth. So you click here, they give you a link to the Bluetooth developer guide, and basically you're off to the races. And if that's the simple documentation, there's also quite a bit of sample code available that you can play around with, some tutorials. There's quite a few articles. A lot of these come from blog postings that the Android developers have put up on their website so that you can follow along with them, and they'll give you advice on best practices, that sort of thing. There's also tutorials that would be a great place to start if you're a brand new developer. I especially recommend the first two here, Hello World and Hello Views. And they also tell you how to get in touch with other developers on IRC, on Twitter. And if you have technical questions, so everybody would like to have somebody next to them that can answer all their questions, right? Stack Overflow is probably the closest thing we have to that on the internet. And the Android developers actually go on there and will answer your questions many times. So, or sometimes I will if you're lucky. So definitely go to Stack Overflow, post your questions, and very often people will reply to you, and you don't get snarky comments or anything like that. I've had a very good experience with it. So that is the documentation. For me personally, I think that's the greatest advantage of programming for Android. There's also background tasks. That was probably one of the most interesting features when it originally came out. Lately, Apple's been making it more popular or more available rather, to get background tasks running on iPhones as well. There's the Android market where you can just submit your application and it's immediately up on the market. You don't have to wait for any review process. You do have to follow the market guidelines. So Google takes the approach of they trust that you've read them and that you're following them until you don't, and then they'll pull your app down very quickly, and if you're lucky, they'll tell you why. But at least it's up there right away. So most people don't have a problem with that. So your time to market is going to be much faster. But with that said, there's a lot of apps of questionable quality on the market. So as an app developer, you're going to have to keep that in mind so that you can get users to come browse for your app, because you're going to be competing with apps that might sound like they have a similar purpose, but in reality, they have a lot less content than you do. So definitely something to keep in mind. And what I have up here right now is the website where you can publish your app. So I just wanted to show you briefly what the web page looks like. So it's just like the iPhone system, which is the only other one I'm familiar with. You put up your promotional graphics, you put up your screenshots, give them a license, title, etc., copy protection, and then you have to agree to their guidelines and you publish it. And before you know it, it's up on the market. There's also other markets available. Amazon just came out with one that seems like it's getting some pretty good traction. And there's a few other smaller ones out there, but Amazon's probably the biggest one that I'm aware of. So you can always look at other options to publish your applications. And you can actually go straight to the consumer. You can put the APK file on your website or whatever and just let somebody download it. You don't actually need to go to a market, unlike the other platforms. That can come in really handy, actually, but you do still have to sign it so that the consumer knows where this app actually came from. Okay, let's see. And the other big difference is that there's extreme platform heterogeneity in Android. And what I mean by that is fragmentation, basically. So there's lots of different types of devices, big ones, small ones, keyboards, cameras, dual cameras. Some have the new NFC readers. So when you're developing an application, if you want to develop a good application, you either need to make limitations on what your app can do and what hardware it needs to support it, or you need to keep in mind all the different variations that are available. So for example, a good application like, say, a Twitter, for example, should be able to run reasonably well on a very small, cheap phone that's being sold in the third world, or on the latest and greatest dual-core processor that's coming out from Motorola, for example. So there's quite a diversity in terms of what different hardware is available. So now I just wanted to talk briefly about the Android stack and give you an idea of how the platform is built up, just so you can get an idea of what you're interacting with. So my favorite part personally is the bottom, the Linux kernel, but I won't bore you with those details. It's basically the Linux kernel with some extra patches built on top of it. And then they have a bunch of libraries. Most of them are open source C, C++ libraries. Those are the ones in green. And you can actually go and get the source for those if you want. Another big component is Android's Java virtual machine. It's not a true Java virtual machine because it doesn't actually run Java bytecode. It actually runs something called Dalvik bytecode. But the way that Android set up the tool chain, you develop your app in Java, it's compiled to Java bytecode, and then it gets sent to the Dalvik virtual machine and actually run. So from your perspective, it really doesn't matter. But what that means is not every single Java library out there is going to be able to work correctly on this virtual machine, but I'm not aware of any big ones that aren't supported. And then the blue section, second to the top, is the application framework. As an application developer, this is where you're going to spend most of your time. Android has one pattern that I think is most pervasive, which is the manager pattern. And what happens is if you want to talk to any sort of shared resource, you usually end up talking through a something manager. So for example, if you want the location of the device, you go to location manager. If you want to send a notification to the user, you go to the notification manager. If you want to bring up the phone dialog, you go to the telephony manager, and so on and so forth. So if you're trying to figure out how to do something on the platform, a lot of times you'll be asking yourself, which manager do I need to talk to? And depending on the service, you might have to get permissions as well. The security model for Android on the app layer is basically, they give you, I personally think they could do a better job on this, but that's the way it is when you install the app, it gives you a big list of what permissions the application is asking for, and then you agree to all of them, and the application can do it all the time, which is a little different than the other platforms, which might ask you more than once. Okay, another big difference with Android is what's called the activity lifecycle. So for those of you coming from desktop platforms or maybe from the web, this is quite different. And the reason that there's an activity lifecycle is because power and network connectivity, that sort of thing, is very scarce on a mobile platform. So an Android application has a few different states that it can be in. So I like to pair them into threes because I think they make sense because all three pairs are coming in and out of a certain state. So the first two, on create and on destroy, that is basically when you create the application at the very beginning and when you destroy it and remove it from memory. So you see how those two kind of go together? Then there's on stop and on start. That is when the application is actually shown and then not shown to the user. And then there's on resume and on pause, which toggle based on whether the activity is hidden, meaning it's behind another activity, or if it's fully visible. So The activity lifecycle, I think, is really confusing for new developers. But if you think about it in those 3 pair of 2 methods, I personally think that's the easiest way to deal with it. Okay, so for those of you that are just getting into this game and you want to get some hardware, I highly recommend that you get one of the Android developer devices. The last 3 are shown here, with the Nexus S on the right being the newest, and the Google Ion being the one on the left is the oldest. And the reason I recommend getting one of these 3 phones is because this is what the Android engineers use to test all the code. So if you want one reference platform where you know your application works on, or if you're only going to test it on one phone, these are probably the best phones to use. You can obviously use any phone that you want to do testing, and depending on the manufacturer and what you're doing with the application, you'll have mixed results. But sometimes you can run into little idiosyncrasies because the software isn't implemented 100% to spec compared to the Google reference platform. So these are basically the gold standard. So I'd recommend that you acquire one of these if you want to do some hardware testing. Okay, so we're all different kinds of developers, and we all like to write in different languages. So here's the different languages that are supported. Java is obviously the main one and the best supported. There's also Java plus C or C++, and that's supported by something called the Native Development Toolkit, or the NDK. So basically you write your Java code, and then you use the Java native interface to create a bridge between your Java and your native code. You can also write the whole application in C++. That's very new. I'm not sure how well it's documented, but the reason that they added that option was for game developers. So if you're a game developer, you'd want to go with that option, writing all in C++, especially if you need OpenGL and really hardware-intensive stuff. You probably know if you're one of these people. Then there's, you can actually write applications in HTML, CSS, JavaScript using a web view. You're not going to get as good performance, obviously, as native code, but maybe you don't need that. Maybe that's the quickest way for you to get an app up or port what you already have or something like that. And then lastly, there's also community support for scripting languages. So if you're interested in scripting languages, you'd want to check out this website here that I'll show you. It's just Google Android scripting, and you should be able to find it. And what it is someone else has gone out there and created some infrastructure to help you write in a few different scripting languages: Python, Perl, JRuby, Lua, Bean Shell, JavaScript, TCL, and Shell. So if you want to do some scripting. Now, like I said, with that user that had the question before, you are going to have to deal with the lack of official library support. So you might have to navigate around a few sticky points. But if you just want to port some existing code, or you want to get something simple up and running, scripting can be very effective for that. Because we all know Java takes a lot of typing, right? So sometimes scripting can be more effective. Okay. And the image I have over here is just showing you how the Dalvik bytecode execution is different than the regular Java. So if you look on the left side of this picture, this is your typical Java running on, phones, servers, workstations, that sort of thing. So you take the Java source code, compile it, you get Java bytecode, which is basically portable assembly. And then that Java bytecode goes and runs on the Java virtual machine. With Android, we still have that initial step of creating the Java bytecode, but then we have a translation step where it goes and it says, okay, Java calls, adding an unsigned integer this, we're going to call it this, and then they change the bytecodes. And the reason that that's done is so that they can save memory and customize the execution for a mobile device. That's mainly the idea. The other main reason they did that is because if you get J2ME, then you have to pay Sun Microsystems, now Oracle, licensing fees, and they wanted to give the OS away for free. And now there's a legal lawsuit going on and lots of drama there. So if you want to know more about that situation, not the lawsuit, but I'm not a lawyer. But if you want to know more about Dalvik, you can look up my article in Jack's Mag. If anybody's interested, I can give you the link afterwards. It's basically an article about why they chose to do Dalvik, some of the differences. I don't know why this whole thing, oh, there we go. Some of the differences between regular Java and the Dalvik Java and different things like that. And that's available on Jack's Mag, JAXMAG. But for the most part, you can basically ignore that you're not using the traditional Java virtual machine. It really shouldn't be a big issue for the vast majority of you. All right, now I'm going to talk a little bit about the development tools. So one nice thing about Android development is it supports all three of the major operating systems. So you don't have to have a Mac, you don't have to have Windows. You can even run Linux if you want to, because the development tools, the officially supported IDE is Eclipse, and Eclipse runs on those three platforms. So all you have to do if you want to get set up is you go to eclipse.org. And you go to downloads. And then you can either get, I believe the officially recommended one is Eclipse Classic. Some people also prefer Eclipse IDE for Java developers. It really doesn't matter which one you take. So go and get your Eclipse, download it, install it, and then once you have Eclipse up and running, you just go to Help, Install New Software, Add, and then you add a URL to where the plugin is, and you can find that address once again on that reference page that I showed you earlier. So you just go under here. So I'm under the SDK tab, and then it's called the ADT plugin for Eclipse, Android Development Tools. And then if you scroll down here, you just grab this URL and put it into this box. That's true, yeah. So thanks for bringing that up, actually. There's another one that you can use, Motorola Development Studio. So Motorola took the Eclipse code. They added in some stuff from the, I think, is it called Sequoia, I believe? Sequoia project. And they basically have all the Android stuff already installed for you, plus some really cool utilities like there's a localization tool which will allow you to take your XML file that has all your strings in it, and you just click the language you want, and say you want to translate it to Chinese. It calls Google's Translate engine, translates all the strings, and plops it in there. That's pretty cool, right? So there's also some skins for the Motorola products, and some other nice features. So I highly recommend that you check that out as well. I'm glad Liz brought that up. Let's see. Moto Dev Studio. Yeah, there we go. So if you get this Motorola Development Studio, you don't need the other Eclipse because it's giving you, it's basically Eclipse with extra stuff added in already with plugins. So you can also add in all the other Eclipse plugins that you like as well on top of this. Thanks. Okay, so for the people that aren't here, Liz just said that basically if you already have Eclipse installed, you can install this functionality as an extra plugin on top of Eclipse. And it has some other nice features like running inside Eclipse. So let's see here. And then there's also the Android NDK, which is what you'll need if you want to develop C, C++ code. And that's here under the same tool as where, the same tab as where you got the SDK from. And it's called Native Development Tools. So to use the Native Development Tools, you download the NDK, and then what you end up doing is making a makefile inside your application. That makefile creates a shared library. inside your application in Eclipse. And then when you install your application on the phone, it's going to take that shared library, put it on the phone, and then it'll have your native code as a shared library that gets linked at runtime. And there's only certain APIs that are supported by the NDK. There should be a list here. OpenGL is one of them, for sure. libz is another one. Let me see. I know there's a list right here. So what I did is I went right under where you download the NDK, and it says what is the NDK. So this list right here, the C library, math library, etc., those are the interfaces that are all guaranteed to have backwards compatibility as Android changes over time. So if you use any other libraries, Google retains the right to break your code at a later date. And probably will. Okay. So now I'm gonna, I have a few pre-baked applications that I can run through, but I was just gonna open up for questions first. And if we don't get enough questions, then I'll go to that. So does anybody have any questions at this point? Over here? Can you modify the native code and the kernel code? Yes, you can. So if, so of course you're not going to be able to modify any of that on the user's phone. I'm sure you realize that. But what you can do is you can download the source code for the whole operating system. Oh, remember the shortcut. Here on android.git.kernel.org. The instructions on how to get the code are right here at the top. And yeah, you can get the code. The latest release that's up there, I believe, is Gingerbread. They haven't released Honeycomb yet. And you can download it, compile it. There's Google hired a guy named JBQ, John Baptiste Courreau. He's an Android open source developer liaison. So they've been getting much better at documentation and support for the open source project. So you should be able to just download it, run make, and then build the whole thing. But at one point that wasn't true. So yes, you can submit patches. Mm-hmm. Yeah, his question was, can you submit code? Yes, you can submit code, and you're very likely to interact with that individual. They accept quite a few patches. But if you're submitting to a project that's upstream from Android, so but what I mean by that is another open source project, like say SQLite, then you'd have to go to that project to submit the patches. But yeah, they welcome patches and they integrate them in readily. I saw some more hands. You, sir?
Can you recommend some of the tools to do profiling?
Sure. So the gentleman had a question about profiling. So there's a few different kinds of profiling we can do. I'm assuming you mean CPU, memory, and maybe power?
Yeah, or database.
I'm not that up on the database profiling stuff, unfortunately, but I do know about the built-in profiling tools. So let me get that. It's not easy to type with one hand here. No, not that much. I can show you my. Sorry, I'm blanking here. I'm trying to bring up my open source project code so that I can show you. Ah, there it is. So I can show you those tools. So what I've done here is that site I showed you just now with all the code for the whole project. Oh, actually, I didn't need to go there. Sorry. And then, sorry, I keep going to different directories. Keep forgetting. Okay, yeah, that's where I want to be. Android SDK. So this is So this is the SDK directory. And then if we go under Tools, can anybody see that? Let me make the font substantially bigger. This is the SDK directory / tools. And we have a few different profiling tools under here. One we have is called Hierarchy Viewer. Very useful. You can get some really big performance gains by optimizing your view hierarchy. So this is a Java app, and will run on all 3 of the major platforms. And basically what it shows you is, oh wow, it's even better than last time I looked at it. What it does is it gives you a tree overview here of your view in memory. So right now I'm showing you the status bar view. So that's the top of my phone. And it's showing me all the different layouts that go into that view. And the reason that that's really useful is because a good app like this one will not have a very deep tree. So when the Java code needs to traverse the tree, it doesn't have to go that far. But a slow-performing application will have a very big tree. So say, for example, you use a ton of nested linear layouts. That's really going to affect your performance because your code's going to have to keep searching through to find views. But if you use something like a relative layout instead, you can shrink the size of the tree, and then your app will perform better. So Hierarchy Viewer is a really useful utility. Another good one, also related to views, let me find the name here. It's called Layout Opt. So Layout Opt, I'm not sure if it'll run because you have to run on layout. Yeah, no, it's not gonna run for me without a layout. But basically what Layout Opt does is it gives you suggestions on your layout. So you load up your view with Hierarchy Viewer, your tree's huge, you're like, holy crap, how do I fix this? You go to Layout Opt. Layout Opt will give you suggestions. Yeah, so that's not really optimization, but I just got excited because I found it. Optimization, if we go over here to the Android tab inside Eclipse, you can see the information on the threads that are running, the heap, yeah, there we go, the heap. You can also look at the allocations, and if you want to get CPU information, what you need to do is run the you put a little snippet inside your code that will dump all the trace information to a file, and then you run traceview right here, and it will bring up a nice GUI that shows you all the CPU information. So if you're interested in these utilities, which I'm sure you will be at some point, there's information about them here on that same website. Yes, here it is. So if you go under Dev Guide, Developing Tools, it talks about all the utilities in that directory in detail. And let me show you the one I was just talking about, so you can see what it looks like. I'm blanking. Where is it? Traceview. It's not here. I don't know why. Oh, there it is. Great. Oh, if you go to the real internet, it's there. Yeah, so that's basically what I'm aware of that's available. And then obviously, you can use other offline tools, just like any other platform. And if you're making your own Android device, you can use your traditional val grind and all those other fancy tools. Does that answer your question? Okay, great. Fragmentation question. I have a picture for you, sir. So he's asking, Marcus fragmented. I'm not rich. I don't have a ton of phones. What should I develop for? And there's a really nice picture. There it is. It's under resources. So resources, platform versions. And that's your pie chart right there, sir. So it tells you that Android 2.2 is quite a big slice of the pie, Android 2.1, and then the rest are quite small. Okay, so the question is, are there differences in the APIs? And are there things you'd have to trade off between the different APIs? Yes, there are pretty big differences. from version to version. For example, the older phones don't support Bluetooth. So if you have a Bluetooth app, you have to have a minimum version. One nice way that you can deal with that is if you go to the reference tab here, you can actually select the API level. And what it'll do is it'll ghost out anything that's not available in that API level. So you can very quickly find out when it was available at. Does that answer your question? Great, thanks. These questions are working out good. Keep them coming. Okay, the gentleman's asking about custom ROMs. So you're talking about Cyanogen, that sort of thing? Yeah, they are based off of the Android open source project. Sometimes what they have to do is they actually have to take files off of your phone, such as proprietary drivers, and then put them back on your phone. So for example, the GPS library, each manufacturer has to implement their own implementation of the GPS library. So usually what you end up doing is just taking the lib off of the phone, flash the phone, and put the lib back on. But Cyanogen does it all for you in the background. You won't even realize that it's happening. Cyanogen in particular is very well documented. They have a nice wiki where you can step through rooting your phone, installing the new ROM, and then tweaking it out and things like that. So, I don't think there's any big forks right now of the Android open source project, but I haven't heard of any, so they should all be coming from there. You in the back, sir? Okay, so the gentleman's saying the emulator is slow. Is there anything faster? A phone. That's basically it. Unfortunately, there isn't. And compared to a platform like the iPhone, which is much faster, the reason that it's slower is because it's an emulator, not a simulator. And the difference is that an emulator actually runs all of the same code as a real phone, but a simulator takes some shortcuts to make it faster. So unfortunately, there's no easy answers there. Most of the time when I do development, I will fire up an emulator and then just keep it running the whole time. It never hurts to have extra memory. I mean, we are talking about Eclipse and Java here, so. But unfortunately, yeah, Eclipse, Android development is RAM intensive. Oh, that's a great question. So the online person is asking about when Android apps will catch up in terms of quality, what's driving that process. Is that it?
What do you think will drive that process?
What do I think will drive that process? So what he's alluding to is what I was saying before, that there's a lot of junk basically on the market, and there's a lot of people just spamming for keywords basically. So you type in some, like for example, if you type in Citibank, I was trying to get a Citibank app the other day, you get a bunch of spammy apps that aren't the real Citibank. So in terms of quality, I think the reason that has suffered is two big reasons I can think of off the top of my head. One is that Android owners don't spend as much money on apps. It's a well-known fact. So the market is huge, right? There's way more people using Android than iPhone, but the market of people that will pay $10 for an app is much bigger for the iPhone. But I personally think that will change as, I mean, at some point you got to have so many people that even that small piece of the pie will become bigger.
Or Google improves the Google checkout process or has a better billing system.
Okay, so the audience person was commenting that Google checkout isn't that great. Maybe that would help.
At least compared to iTunes.
Compared to iTunes, okay. And then the other thing was, is there anything I can think of that would drive that? Another thing I could see driving that is the other people's markets, such as Amazon. I can't think of anything, but maybe they'll innovate in some way that'll make it more attractive for better developers to come along. For example, they could give them they could take a much lower cut, because Google takes about 30% of your app sales, I believe, which is the same as iOS, or at least last time I used iOS. And if somebody came along that only did 10% and could actually get your app sold, that would definitely help out quite a bit. So the gentleman wants to see the structure of an app. All right. Thanks so much for the questions, guys. Makes it much more beneficial for both of us. So one thing I wanted to show you is how easy Android makes it for you to get really interesting views without a lot of code. So for example, here is an application that just brings up a map view. So I'm going to run it here in the background, and then I'll go through how it works. So what we have here is an Eclipse project. The source code, we just have one Java file. That Java file is extending, so it's basically subclassing an activity that's in the API called map activity. And then there's different hooks that we talked about earlier, such as onCreate, onStart, onStop, that sort of thing, where you can add in your code that will then alter what the user sees on the screen. Because if you don't touch anything, all they're going to get is a map that they can't do anything with. So what this code does is it sets up the views, sets up the controls, gets a location listener. So like I mentioned before with the managers, to get your location, you have to talk to the location manager. Location manager asks, do I have permission to get location? And then we'll give the application a callback when it has the location. And so in terms of Java code, you can do quite a lot just in this onCreate method. You can think of it as being analogous to a main on a platform application. And then similar to what the previous speaker spoke about with model view controller, they separate the view logic from the business logic or the logic that's actually doing the work. And so the way that that's achieved is by putting the view in XML. So this is the map view. This is all that's required. You basically add a layout, and so the layout holds a view, and then the view we're holding inside right now is a map view. So it's just these two elements of XML. And this is another one of the reasons I think that Android has really taken off, is because you don't have to do as much coding to get really good output. So you just have these two little tags for XML. And then there's also a very important file called the manifest. What the manifest does, when you install the application, it tells the Android system things that it needs to know about your application, such as which activity do I start first? What permissions do you have? What sort of intents do you support? An intent is kind of like a signal to your application. I don't want to get into that. It's kind of a new concept. So anyways, you got the manifest, you have the XML for views, and then you have the Java. So this line right here, set content view r.layout.main, is what loads that XML file. There's a Java file called r.java that's automatically populated with constants that represent your XML files. So you're basically going to that Java file and saying load this constant which represents the XML file I just showed you. And then, if you run it, you can see, it's not working because of the internet. I can show you on my phone here. Application, you can see at the top here it says map demo. And so I was running this on my phone when I was on my way here. And that's really all it takes to get a map view up and running. So you have to go get a map key. I didn't cover that, but that's all it takes to get a nice little map view here that your user can play with. So you could toss a view on top of that and make a nice little app without much coding at all. You could easily do it in under an hour once you get used to the process. So I believe I'm out of time, right? Okay. So thanks so much for your attention, and I'll be out there in the hall if you have any extra questions.